Okay, this is going to be the first tutorial of a series of tutorials, um, pretty much for beginners, on how to use Open Music, the software developed by Aircam. So to start off, my name is Federico. By the way, I wanted to give you a little bit of a description of what Open Music actually is, and so I just copied and pasted shamelessly this description from Wikipedia. So Open Music is an object-oriented visual programming environment for musical composition based on Common Lisp. And it says here, and that's true, of course, that you could also use it for an all-purpose visual interface to Lisp programming. In other words, you could do regular Lisp programming, not necessarily musically related. If you don't know what Common Lisp is, you might want to check out this great book, the title of which you can see right here, Common Lisp, A Gentle Introduction to Symbolic Computation. It is not strictly necessary that you're familiar, either a programmer, I'm not a programmer at all, or that you are fluent in the Common Lisp language, although if you know the language, or if you at least understand the structure or the grammar of the language, you will have a much easier time coding with Open Music, because just things will make a lot more sense. And sometimes when weird things happen and it just is hard to understand, seems too illogical sometimes, why things behave in a certain way. If you understand the language, it'll make a lot more sense. But anyway, I did read this book partially before I started to use Open Music, and I think that did help when I got started. But I don't think it's strictly necessary, so I wouldn't feel intimidated in any way. Like I said, I am not at all a programmer. Okay, so let's close this. Oh, this is, by the way, a list of well-known composers that use Open Music. You'll recognize maybe more than a few, but certainly Tristan Morale and Kaya Sarayaho. So it is used by, of course, Brian Ferniho as well. It is used by composers that do spectral music, but not exclusively. You could do all sorts of things with it, mostly things like motivic manipulation. You could take a set, you could expand it, move it, transpose it. That's just one of many things that you could do. So I don't want you to feel like I'm limiting your possibilities. But let's go ahead and get started. I'm assuming you already installed Open Music. If you haven't, you can just Google that. You shouldn't have any trouble. So when you double click on your Open Music, you'll get this window that asks you if you want to use a previous workspace, which I want to do because I've created one before. Of course, if you haven't, you can just create one. It's pretty intuitive. It's almost like a desktop. What you'll have here, that this is my workspace. This is not the default workspace. This is just my cluttered workspace here. So I created already a new folder called tutorials, which I believe is empty. No, it isn't empty. So I'm going to erase these. No, I can't do that way. I'm going to just clear, duplicate. Clear them all. Start from 0. There. Okay, so what I'm going to do, so let me go back one step. So I double click on my folder, and then I right click on here, and I say new patch, and I'm going to double click in here. I'm going to call it tutorial 1. Okay, then when I double click, I get this blank canvas. Okay, I'm going to close this little thing here because I want to tell you what that is in a minute. So it's just a blank canvas. If you're used to doing visual programming, you'll be familiar with this sort of daunting white canvas. It'll be the same if you've used programs like MaximSB, for example. So this is an object-oriented language, which means you won't be coding in the sense that you won't be actually writing code, but you'll be using objects. So it's a more intuitive way of coding. So the first thing we're going to do is maybe take a look at these menus here. Other than the usual menus, you have two menus, one called classes, the other one called functions. The difference between the two is fundamentally that the classes are objects. So let's go ahead and experiment with that. We'll go through here, we'll go to score, and we'll pick the note object, okay? Now we could also double click and type the name of the object, and we get the same result. That's what I usually do if I know the name. But anyway, so we'll leave this object alone for a second. Functions are actually actions. So they're list functions. You know, addition, adding, pick the first out of a list, or do reverse the list, remove this element, so on and so forth, okay? You don't need to worry about knowing what all of that means. We're literally going to start from the beginning. So what can we do with this? Well, let's go ahead and open this a little bit more. One thing you're going to want to learn how to do is, of course, select the object. So if I click outside, it's not selected. When I click in it, if I press M, I now see the content of the object. This doesn't work for every object, but it does work for the score objects. So now I can see that there's a note in there. It's a little bit hard to read, and actually usually you won't be able to tell exactly what it is, and you'll be able to see more or less what the range is, but to really see clearly what note that is, you have to double click the object and it'll open it, and now you see that it's a C, although here it looked more like a D than a C. But let's close that for now. So if we look at the inlets, we see that there's 5 inlets, and the first one, well, they all have default values in them. To know what the inlets are, and this is not the same for every object, so you're going to want to learn to do this. You want to select the object, press D, and what that does is it opens documentation, which is extremely helpful, if not absolutely necessary. So it'll give you a description by inlet from left to right what they are. So the self inlet basically recognizes information coming from that's specific to this object, and that will become really useful later on, but for now we're not going to worry about that. The next one is the MIDI C, which is short for MIDI sense, and the next one is velocity, which is in MIDI values 0 through 127, 0 meaning no volume, 127 meaning full volume. The duration in milliseconds, so 1000 would be 1 second, and the MIDI channel. So we don't need to worry about any of these except the second one right now. So real quick, here's what MIDI sense are. If you've worked with MIDI at all, you know that 60, oh, sorry, by the way, what I just did now is I just double clicked, and instead of typing the name of an object, I typed a number, and that becomes a number object, and which is recognized by these inlets. So if you type 60 in MIDI, that means middle C. Now Open Music actually uses MIDI sense, which means that instead of 60, middle C is 6,000. So why would that be? Well, that's because it allows for an easier description of non-tempered of non-tempered pitches. So for example, if in MIDI 61 is C sharp, so 60 is C, 61 is C sharp, 62 is D. In Open Music, 6100 is C sharp, and 6200 is D. But because I have these 2 additional zeros, I can do very easily microtones. So for example, let's say 6150, which is between 61 C sharp and 62, which is D, is actually going to be a C 3/4 tone sharp. So, well, let's see if that works. What I do is I connect the outlet of the number, there's only an outlet, to the second inlet, which is the MIDI, if you remember. If you forgot, you can just check the documentation, see the MIDI set value. So what I do then is I select the object, then I press V, which means evaluate. So that the object won't actually pull in information from the inlets unless you evaluate it. So you need to remember to do that. And if I double click it, you can now see that it shows a C 3/4 tone sharp. Okay, you can actually hear what it sounds like. Let me make sure I have the right player. There is this one thing about that, by the way, which is that if you want to hear microtonal value, microtonal pitches, you're going to have to use the player called microplayer. By default, Open Music will use MIDI share. I'm not sure if with the latest version of Open Music it'll install by default microplayer. If you haven't, I know it didn't when I did it. I had to kind of go searching for it in the Aircam forum, but I did find it. It wasn't particularly hard to do, and you're going to want to have it. And this is actually just a max patch that works in conjunction with Open Music, and it allows you to play all sorts of microtones. So it's pretty cool. So I just open it. This is what it looks like. You don't really have to do anything with it. I'm just going to put it to the side, and if it works correctly, you hear that note, which I don't know if you know, it's a C3 quarter tone sharp. Okay, very good. Let's go back to our C. So one of the things, I have a couple of more minutes, and I'm going to take a break and do a second part to this because I have a 15-minute limit. So one of the things you could do now with this is, for example, take a well, let's get rid of this. Let's work with a different object now. Let's erase this. We're going to double click and type chord. Okay. Of course, the difference between the node object and the chord object is that the chord object allows you to write in chords. It recognizes chords. So first of all, the format for that, and here's where a little bit of Lisp knowledge comes in handy, is that you have to put, when you put a list, you need to put it in parentheses. So for a C major triad, you would have 6,000, 6,400, 6,700. Let's see if that's true. We evaluate it. Okay, what I just did now is I selected the chord object and I press spacebar, and it gives you a preview of the sound. You could also double click it, open it. That was not what I was trying to do. There we go. Okay, so let's close it. All right, very good. One more thing about this. When you double click it, and this is true for all of these score objects, there's something we didn't talk about, which is those two menus here, the staff menu and the approximation menu. The staff menu allows you to pick how you want to see this. So for example, if I go to the top, it'll put all of it in bass clef, the F clef, G clef, all treble clef, grand staff. Then you could only do 2 treble clefs. The top one is actually 2 octaves higher. So this is for you to see pitches that are extremely high without using ledger lines, or at least reducing the number of ledger lines. And you can go all the way to down here, where you can see 4 different staves. This one being 2 octaves higher than regular treble clef, bass clef, 2 octaves below bass clef. So extremely large range. So I typically just keep it with a grand staff. There should be more than enough for most situations. Anyway, another quick thing. Oh yeah, sorry, I forgot to talk about another thing. The other thing I was going to talk about is the approximation. This has to do with how Open Music is going to interpret the MIDI sent values that come in. It's going to actually round them for you to and display them to the closest value that you indicate. So for example, if I say 1, that'll be to the closest whole tone. If you do, so these are kind of, I've never used these. So typically it'll be to the nearest half step. So that's basically just tempered. Then you could do another very common one would be to the nearest quarter tone. Of course here you don't see any difference, and that's because none of these are microtones. But if I were to change, let's say the second one to 6450, and I did this, you would see now that the E is quarter tone sharp. But if I just used the half step approximation, it would actually move it up to an F, which is closer. It rounds it up to an F. Suppose it could have rounded it down to an E, but it just, maybe by default it goes up. Anyway, so that's the deal with that. You could depends on, this obviously depends on what kind of thing you're going to be dealing with, but it comes in handy if you're doing things like spectral analysis with the pitches, or if you're working with frequencies. But let's talk about this in the next tutorial.